Hello, this is the review for the TOEIC exam, and we start the review with a problem from chapter 11. We have a preference table here, and we want to find the winner of the election with four different methods. And the first method is plurality method. By plurality, we consider only the first line, only the first places. In the preference table, we have ballots organized in several groups. So here we have four groups. In the first group, there are 31 ballots, and on 31 ballots, A has the first place. B has the first place on 20 ballots. C has the first place on 15 ballots, and D on 28 ballots. So A is the winner by plurality since 31 is greater than any other number of ballots of first places. The second method is plurality with elimination. We also consider first places only, but we will eliminate the weakest candidate until one of the candidates get a majority. So first question will be, what is the majority? This is the half of the votes and a little bit more than half. So if the half is a fractional number, then like 45.5, then we take the next integer, 46. So if it is an integer, then we take the next integer. Okay, we add the ballots together. So they are 94 over 47 ballots. So the next integer will be 48. The majority is 48. So A had 31 ballots, but it is less than majority. Then that's why we need the second round of election. We eliminate the weakest candidate. So 31, 28, 20, 15. 15 is the lowest number, so we eliminate C. We remove C from all the ballots and we move the candidates that are below C up. We get a new table without C. So instead of C in the last column, we will have B. So A also goes up and D goes up. So this is the new preference table. And now you see that B has 20 plus 15, 35 first places. But 35 is still less than 48. That's why we remove the next weakest candidate. So this time it is D with 28 first places. So we remove D from all ballots. And we get a new table without D. Now B has 28 plus 20 plus 15 first places. So A has 31 and B has all the rest. 63 is greater than 48, of course, the majority. So B is the winner of the election by plurality with elimination. The next method that we consider is Borda count method. We assign points 4 for the first place, 3 for the second, 2 for the third, and 1 point for the fourth. So A has 31 first places, so it has 31 times 4 points. Then A has 28 last places, 28 times 1, another 20 last places, and 15 third places, 15 times 2. Now we count the points for B. So in the first group of ballots, B has the third place, so 31 times 2 points. Then 28 times 3 points, so 3 points for the second place, and 20 first places, plus 20 times 4, and 15 second places, 15 times 3. 271 points. Then C, in the first set of ballots, C has the last place, so 31.1. Then 28 third places, 28 times 2, 2 points for every third place. Then 20 second places, 20 times 3, and 15 first places, plus 15 times 4, 207. And now D. On the first 31 ballot, D has the second place and 3 points for every, plus 28 times 4. Since on this 28 ballots, D has first place, plus 20 times 2 for third place, and plus 15 times 1 for 15 last places, fourth places. 260 points. So the greatest number of points is 271. So B is the winner by Borda count methods. So for the moment, we have different winners for all three methods. Let us consider the fourth method, pairwise comparison. We will compare the candidates in pairs, and first we will list all possible pairs. We will start with A versus B, A versus C, or A versus D. Then we start with B. We look only forward, we do not repeat the pair BA, so B and C, B and D. And the last pair starting from C, C and D. And now we will count on how many ballots A is above B. So A is above B on the first 31 ballots, 31 points for A. On the next, B above A in the next three groups, so 28, 20, and 15. B is definitely the winner in this pair. Let us make another table to count the points. A, B, C, and D, and B gets a point. The next pair, A versus C, in the first set of ballots on 31 ballots, A is above C, so A gets 31 points, but on the other, the same number 20, 28, 20, and 15 ballots, C is above A. So in this pair, C gets a point. Next pair, A, D. A is above D on 31 ballots. Then D is above A on 28. D is above A on 20. And A above D on 15. So here we must find the sum to determine who is the winner. 46 for A and 48 for D. So D wins in this pair. D gets a point. The next pair, B and C. B is above C on 31 ballot, on the next 28, and on the next 20. So C is above B only on 15 ballots, so B is the winner in this pair. B and D. D is above B on 31 ballots, on the next 28. B is above D on 20 ballots, and on 15. So 35, the sum is 35, and 59. D wins in this pair, D gets a point. And the next point will decide whether we have a winner by this method. We compare the ballots for C and for D. C is below D on 31 ballots, 31 points for D. Then the next 28 points for D, and C is above D on 20 ballots and on 15 ballots. So 35 versus 59. D wins in this comparison and gets another point. So D wins by pairwise comparison, getting more points than any other candidate. Okay, 4 different methods, 3 different winners. Next question is about weighted voting system. And first we have here 4 voters and quota Q, which is unknown, and the number of votes by the of voter A is also not given. Suppose that voter A has 4 votes. So we have situation, quota Q is not known, and 5 voters with 5, 4, 8, and 1 vote. Which value of Q would give all voters veto power? So everybody has a veto power if only all their votes together can pass a resolution. So the sum 5 plus 4 plus 8 plus 1 must be equal to quarter. So quarter must be 18. Then every vote has a veto power. Suppose that quarter is 20. What is the minimum value of A that would make resolutions passable? A similar question. So if the sum is less than 20, then no resolution is passable. So the sum 5 plus 8 plus 8 plus 1 must be equal to 20, and it is only possible if A equals 6. Suppose that quarter is 15. What is the minimum value of A that will make A become a dictator? Dictator means that A can pass any resolution, nobody else can pass it. So 5 plus 8 plus 1 is 14, so less than 15. The 3 voters cannot pass the resolution. So A, to be able to pass a resolution, must have the number of votes at least 15. Then A can pass any resolution on his own. Suppose that 3 or 4 voters have veto power. Identify the voter without veto power. So 3 or 4 voters means that they can pass without one voter. This voter must have the smallest weight, so it must be the voter with the weight 1. The undergraduate student is taking 5 equally weighted courses during the fall. The student has estimated their probabilities of getting certain letter grade in each of those courses. What is the probability of the student earning letter grades that are all B's? So this is probability of the intersection. So we can think in stages. So what is the probability of getting B in history? Then what is the probability of getting B in introduction to engineering given that it has B in history and so on. So we have here a product of 0.25 times 0.20 times 0.20, the probability of getting B in chemistry, 0.50 times 0.50. Multiplying them together, you get 0.0025. So very low probability because there are a lot of outcomes in this event. So a lot of different possibilities and combinations of grades. So if you want to write in the form of percent, we can write 0.25%. Assume that letter grades correspond to GPA points as 4 points for A, 3 points for B, 2 points for C, and 1 point for D. What is the student's expected value in chemistry? So expected value, we have a formula for expected value, is a product value times probability. So the values are 4, 3, 2, and 1. So the values. Probabilities are given in a table. We will consider now this line for chemistry. These are the probabilities that we will consider for every outcome. So first outcome A, the value is 4, probability 60, or 0.6. We always use a decimal form of probability. The next outcome is B. The associated value is 3, probability is 0.2. The next is C. Associated value is 2, probability 0.2. Probability of D is 0. So, and then we calculate the sum. So 4 times 0.6 will be 4 times 6, 24, and decimal point moves to the left. 2 times 3 is 6, and decimal point 1 placed to the left. 2 times 2 and 4, and decimal point 1 placed to the left. So 0.6 plus 0.4 is 1. 1 plus 2.4, 3.4. So the expected value in chemistry is 3.4. Let us find expected value in college algebra. So now we will consider this line with percentages of college algebra grade. We have outcomes A, B, C, or D. So the value of outcome A is 4, multiplied by the percentage of the probability of this value in college algebra is 10%, so 0.1 in decimal form. Then B, probability of B, 0.5, plus C, 2 points for C, and probability 0.4. 4 times 0.1 is 0.4, 3 times 5, 15, and that's more point to the left. 2 times 8 is 2 times 4 is 8, and 0.1 placed to the left. So we have 1.2 plus 1.5, 2.7. The expected value in college algebra is 2.7. Two dice are rolled, and we have two questions here. Find the probability that neither die shows 1, and what is the probability of getting a sum less than 9? To answer this question, we need to consider the sample space of this event, rolling two dice. And there are 36 outcomes, and it is helpful to see these outcomes in front of you. So we have 6 lines. In the first line, the first die shows 1, the second die shows the numbers from 1 through 6. So 36 outcomes, and now let us answer the first question. Find the probability that neither die shows 1. We can consider the complement of the event. At least one die shows 1 in this column, the second die shows 1, and in this row, here the first die shows 1. So we have 6 in the line plus 6 in the column, and we have counted this outcome twice, so we subtract 1. 12 minus 1, 11 outcomes showing 1. So the rest 36 minus 11, 25 outcomes without 1. So we can find the probability that neither die shows 1, as the number of outcomes in the event no 1 divided by number of outcomes in the sample space. So 25 over 36, and we can simplify this fraction, so we give the answer as such a fraction. Please read carefully what is written, give it as a fraction or as a decimal. So the question B, what is the probability of getting a sum less than 9? We must find the outcomes with the sum less than 9. First, let us find where the sum equals to 9. The same sum is usually on the diagonal. 3 plus 6, 4 plus 9, 5 plus 4, 6 plus 3. On this diagonal, less than 9 is above the diagonal. So you can just count these outcomes, or you can find the easiest to find the complement. We have the total greater than or equal to 9. So this is the complement. It means that on the rest we have total less than 9. So the number of outcomes in the sample space is 36. 36 minus 9, 36 minus 10 is 26. There are 26 outcomes in the event. So the probability of getting sum less than 9 will be the number of outcomes in the event less than 9, total is less than 9, divided by number of outcomes in the sample space. The number of outcomes in the event is 26, in the sample space is 36, and we can simplify this fraction. Both numbers are even, so we can divide by 2, 13 over 18. Another probability problem in a class of 56 students. So the total number of students is 56, sample space. 22 students have 80% or better on their first exam, 19 students 80 or better on the second exam, and 25 students on the first and on the last, and 25 students have 80% on at least one of the exams. So if we represent as a set, exam 1, exam 2. So on at least one of the exams means the union of events, E1 union E2, and here we have 25 students with one of the exams, with having B, at least B on one of the exams. So please read carefully the questions. What is the number of outcomes in the sample space? If we randomly select one of the students from the class, it is 56. What is the probability that a randomly selected student has the grade below B? So on the first exam, so 22 students have B or A. So the rest, the complement of this event, so 56 minus 22 have below B. The probability, to find the probability, we must divide by the total of 56. It will be 0.6171 or 61.71%. What is the probability that a randomly selected student has a grade below B on the second exam? Again, we have 19 students with B or A. So below B will be 56 minus 19 divided by the total, 0.6607 or 66.07%. The last question, what is the probability that a student has more than 80% on both on the first and on the second exam? So it means we are interested in this part, the intersection of two exams. So more than 80, so A and A or B. So we have 22 students in the event first exam, 19 in the second exam, and 25 in a total. So we have a formula for intersect for union of the events. So probability of the union equals probability of the first event plus probability of the second event minus probability of the intersection. Probability of the union, 25 over 56. Probability of B or A on the first exam, 22 over 56 plus 19 over 56, and we want to find this probability of intersection. Let's call it just P. So, and we have to solve this formula for P. So you can use these numbers as decimals, or we can add P to the left and to the right, and subtract 25 over 56 from the left and from the right, and we get that P equals 22 over 56 plus 19 over 56 minus 25 over 56. All three fractions have the same denominator, so we can write them with the same denominator and find the sum. 22 minus 25 is -3, 19 minus 3 will be 16 over 56, or we can simplify it, dividing by 4, or we can take a calculator and find the decimal form. And the next problem is from the statistics chapter. We are given a small data set and we want to find mean, median, mode, range, and standard deviation. To find the mean, we just add the numbers, find the sum, and divide by the number of the elements. So there are 4 and 4, 8. So we add 26 plus 12 plus 25 plus so on. So we get the sum equal to 174 divided by 8 will be 21.75. Then to find, which is the mean, to find the median, we must arrange the numbers, for example, from the smallest. So 12. Okay, we have also 5 that must be in front of 12. Then next will be 16. Be careful by listing the numbers, don't skip anybody. So then we have 3 times 25. Then we have 30 and 36. Since we have 8 numbers, median is determined by 2 numbers in the middle. So they are the same, but in case they are not the same, we find the mean. 25 plus 25 over 2, which is 25, and 25 is the median of the data set. Then we find the mode. The mode is also 25, since 25 is repeated 3 times. If there is no mode, just write no. The range is the difference between the greatest number. So we look in the set when it is already arranged, 36 minus the smallest number, minus 5. And the most difficult part, the standard deviation. So we must find the differences from the mean. So we take all the numbers. 36 minus 21.75. 12 minus 21.75. 25 minus 21.75. So in this case, we can multiply it by 3 so in order not to repeat it. Then 16 minus 21.75. And then we must square every difference or deviation. So here we first square and multiply by 3. And then we find the sum of these squares. So it is recommended to do it a couple of times to be sure, because there are a lot of steps. So I have done only once and got 711.5. Then we divide by, not by the number of elements. So the number of elements is 8. We divide here by 8 minus 1. So we divide by 7. So we get 101.64. And then we take the square root of this answer, 101.64. The square root is approximately 10.08. So this is the standard deviation of this data set. Then now we consider normal distribution. Suppose that the scores in a class of 400 students are normally distributed. The distribution's mean is 80 points and standard deviation is 5. Determine what percent of scores do we expect to fall above 75. So when the mean is 80, so we have 80 here, then so we are going to apply the rule 80, 68, 95, 99 rule. So we will look where is the one deviation to the right, what score is one deviation to the right. So deviation is 5, so one deviation to the right will be score 85, 2 deviation will be 90, 3 deviations 95, and to the left 80 minus 5, 75, 70, 65. So we are interested in scores above 75 from here. This is one standard deviation from the mean, to the left from the mean, and we can divide this into two parts. So we have first the half of the 68 interval. So the half of 68 will be 34%. And then we have one half of the scores, and 50%. 50%. So there are 50 plus 34%, 84%. How many scores do we expect to fall above 75? There are altogether 400 students, 400 scores. We want to know what is 84% of 800. So we multiply 84 by 800 to get the number of scores, which z-score corresponds to the exam score from the part A or B. So z-score is the number of standard deviations from the mean. So, and we know that 75 is one standard deviation from the mean. And this one is to the left, so the z is negative. Z equals -1. What percent of scores do we expect to fall between 80 and 95? So let us recall mean is 80, then one standard deviation 85 to 90, 95. So this interval from mean to 3 standard deviations. And we know that within 3 standard deviations from the mean, there are 99.7% of all scores. So this is the half of this percentage. So 99.7 over 2%. 99.7 over 2. Calculate the exam score associated with the z-score equal 1.8. So here we will use the formula connecting raw scores and z-scores. We want to find raw scores. Z-score is given 1.8. X is the unknown. Mu is the mean of the set, which is also given 18. Standard deviation is 5. And we will want to solve this equation for x. So we solve for x. We want to isolate x on one side of the equation. So let us multiply by 5. First we read off this denominator here. 5 and 5 will be cancelled. We have 9 equals x minus 18. And then we add 18, so that 80 goes to the left. And we got x equals 89. The raw score is 89. The next question is to find z-score, knowing the raw score. So we use the formula directly. Z equals x minus mu over sigma. We substitute 72 for x, 80 for mu, and 5 for sigma. -8 over 5 or -1.6 is the z-score of 72. And the last problem, construct a histogram for the following data set. Use 5 classes with the uniform class width of 10 points. So use the low limit of 0. So you have the first class from 0 to 10. So 10 will be included in the next class. So we must decide what we'll do with the boundary values. So we will include the boundary value to the next class then. 30, 40, and so 50. We have a couple of typos here. So, and then we and then we just count how many numbers fall to each class. So we just go from number to number. So we have 20, 20 goes to the third class, then we cross it out. So then 25 to the same class, 24, 25, 28. Then we have 35, 35 goes to the class with 30, 47 here, 36, 12, and you continue on the same way. Five goes to the first class. So if we have 37, it goes to the class starting with 30, 16 to the class starting with 10, 42 goes to 40, and so on. And then we count how many numbers we have in every class. And the last step, we draw the histogram. On the x-axis, we show our classes from 0 to 10, 20. And on the x-axis, we must have a scale. So we have the frequencies until 20. So let us take 5, 10, 15, 20, 25. So the high of the bar from 20 to 30 will be almost 25, so 24. So the neighbor bar will be 13. Here will be only 3. Then from 30 to 40 we have 16. From 40 to 50 only 8. So this is the histogram representing this data set. Okay, thank you so much. Good luck on the exam and let me know if you have any questions.